Hello students and welcome to part 2. In this part of the lesson we are going to look at 4 real-world examples and then summarize what we've learned. In this example it says, Jamie spends the same amount, which we know means to be equal. Jamie spends the same amount of money each morning. So every single morning she spends the same amount of money. On Sunday, she bought a newspaper for $1.25 and also, which I know will be added, and also bought 2 donuts. 2 times the price of a donut. So I'm going to put a D for the price of the donut. On Monday, she bought a newspaper for 50 cents and bought, so we'll be adding 5 donuts, or 5D. What is the cost of 1 donut? Well, I'm going to let the variable D be the cost of 1 donut. Now, I know from this first sentence that she spends the same amount of money every day. So I know that Sunday is equal to Monday. In other words, the amount of money she spends on Sunday is the same as the amount of money she spent on Monday. Well, we can write an expression for each of those days. So for Sunday, she bought a newspaper for $1.25, so I'm writing 1.25, and also, which means to add 2 donuts. So I'm going to put 2 times D, which is the cost of 1 donut. Now remember, Sunday is equal to Monday, and we can also write an expression for the amount of donuts, or the amount of money she spent on Monday. Well, on Monday, she bought a newspaper for 50 cents, sorry, at 0.50, and bought, which means add, 5 donuts, so 5 times the cost of a donut. Now, if you look at our equation, we have like terms on opposite sides. We're going to have to eliminate one of them. I'm going to subtract 2D from each side. I get 1.25 is equal to 0.50 plus 3D. In other words, 3 donuts plus 50 cents is the same as $1.25. Now I'm going to subtract the constant. I'm left with 75 cents is equal to 3 donuts. Divide each side by 3. I get 1 donut, or D, is equal to 25 cents. 75 cents split 3 ways is 25 cents. So I can restate my answer. The cost of 1 donut is 25 cents. Let's look at another real-world example. Sean and Laura have the same number, well that means equal, so Sean is equal to Laura. Sean and Laura have the same number of action figures in their collection. So however many Sean has, Laura has the same. Sean has 6 complete sets, so I'm going to put 6C. Because I don't know how many figures that is. I just know that it's 6 sets, so 6 complete sets, plus 2 individual figures, or 2 more. Well, Laura has 3 complete sets. Will that be 3C plus 20 individual figures? How many figurines are in a complete set? So I'm going to let C stand for the number of figures in a complete set. And we also know that Sean's number of figures is the same as Laura's. So Sean's can be described by 6 complete sets plus 2, or 6C plus 2, and Laura's can be described as 3 complete sets, or 3C plus 20. Now we see we have like terms on each side, so we'll subtract 3C to eliminate the variable on the right side, because 3C minus 3C makes 0. We have 20 left over, so we're left with 3C plus 2 equals 20. Take 2 away from each side. 3C is equal to 18. Divide each side by 3. we get 1C, or 1 complete set, is equal to 6. So then you would restate your answer. There are 6 figures in a complete set. Each day, the triathlon team runs the same distance on campus. So every day is equal. On Mondays and Wednesdays, they run 3 laps, so I'm going to put 3L, on the track, plus an additional, so plus 5 miles. So this is going to be Mondays and Wednesdays are going to be equal to something. On Tuesdays and Thursdays, they run 4 laps, plus an additional 2.5 miles, so plus 2.5. So now we know that what they do on Monday and Wednesday is the same as what they do on Tuesday, Thursday. Well, on Monday and Wednesday, we can describe their distance by 3L plus 5. 3 laps plus 5 miles, and Tuesdays and Thursdays, we can describe it as 4L plus 2.5 because they do 4 laps plus 2.5 more miles. Now our question says, how far is 1 lap? So we're going to let L stand for the distance of 1 lap. And then when we take our equation, which I'm just rewriting here, and solve it, we'll be able to figure out what L is. As you can see, we have like terms on opposites, so we'll take 3L away from each side. We're left with 5 equals 1L, or just L, plus 2.5. Take away 2.5 from each side. You can think about 5 as 5.0, and you'll get 2.5 left over when you subtract. So each lap is 2.5 miles. Let's look at one more example. It says both figures have the same perimeter. Well, we know that their perimeters are equal then. We also know that perimeter is the distance around the outside of a polygon. Which will help us with this problem. So in other words, the perimeter of the rectangle is equal to the perimeter of the triangle. Now remember, be careful with the rectangle because even though they're only showing us 2 sides, we have to add all 4 together to get the perimeter. So this side is x and this side is x plus 20. So to describe the perimeter of the rectangle, we would have to write x for this side plus x plus 20 for the long side plus another x for the short side plus another x plus 20 for the bottom. And that'll be equal to the perimeter of the triangle, which is x plus 55 plus x plus 15 plus x plus 50. So we get x plus x plus x plus x makes 4x, and 20 and 20 make 40, so we get 4x plus 40 for the simplified perimeter of the rectangle. On this side we get x plus x plus x, which makes 3x. 55 and 15 makes 70, plus 50 more makes 120. Now, we have like terms on opposite sides, so we'll subtract 3x from each side. 4x minus 3x makes 1x, or just x. So we have x plus 40 equals 3x minus 3x, which is 0, and 0 plus 120 is 120. So we'll subtract 40 from each side. We get x equals 80. Now, 80 is not the perimeter. 80 is the value of x. So we'll have to substitute 30 back in and figure out the perimeter. Sorry, 80 back in to figure out the perimeter. This is 80. this is 80, this is 80, and this is 80. So we have 80 4 times. So 80 times 4, you know, is 320. Plus we have two 20s, which make 40. So our perimeter is 360. We do not need to substitute it back in here because we know it has the same perimeter, but that would be an excellent way for you to double check your work. So the perimeter is 360. So let's summarize what we've learned. To solve an equation, we first have to distribute, combine like terms on the same side, combine like terms on opposite sides, and then use inverse operations to isolate the variable. When we solve an equation with like terms on the same side, we will combine the like terms. But when they are on opposite sides, we will eliminate like terms until only one of the variable remains.